This is Edgar van Essen, I'm Managing Director of Switch Data Centers in Amsterdam. I would like to discuss with you the evolutionary scenarios we see for next-gen generators. This is a talk for digital infra. Let me switch to my presentation, just a moment. So welcome. I hope you can see the screen. Switch is an Amsterdam-based sustainable data center operator and developer, and we've been in the business for more than 15 years. Currently, we have quite a big portfolio of operating data centers, which we run under our own brands, which is both wholesale as retail co-location. But also we're developing data centers for other parties as well as we're a developer. So we play in the Amsterdam market, and unlike all the other players in the Amsterdam market, we're still 100% Dutch. So as said, we already own and run data centers for quite some period of time, and therefore we have been experimenting a lot with all kinds of technologies, and we have many years of operational experience. And as a Dutch company, we could only survive by always being at the forefront of innovation in the market. And in Amsterdam, innovation is almost equal to sustainability because there's a lot of pressure from both the community as from the country itself. And if you want to succeed in data centers in Amsterdam, you have to be leading in sustainability. So therefore, that's that we are proudly part of digital infra, where we share our vision and our activities to a larger set of the world, and hopefully you can do something with it. As said, we are there for a long time. We've also quite interesting track records. We've been buying a data center from IBM and selling these back. Including a lot of high-end customers, but also, for instance, we sold off our initial EMS1 data center to Equinix, and in the meantime have built a dedicated, the only white label tier 3 data center I know of in Amsterdam for a specific large customer that we also run on a PUE of 1.12 on an annual base. We do that by again, by leading in innovation, and we have plenty of experience, but also we like to be disrupting and always challenging the status quo of the industry. And specifically, if you want to be at the forefront, it is not the smartest way to just follow and copy what the rest is doing. Actually, we very much challenge also the large players in the world, and have a very specific relation with some big suppliers who see us as part of their innovative, let's say, forward-looking customer set. And for that reason, also we get a lot of extra attention and help from some big companies behind us. In the meantime, we made some very interesting headlines. We are the first data center in the world that actually wants to start making waste heat in a data center, a business model, and not so much only a freebie. For us, specifically, if the heat is at a specific amount of degrees of 50 degrees Celsius plus, it doesn't make any sense to give it away. Actually, it becomes a good with a value that we use in trading. And customers who actually help us generating that heat will get a discount on their power bill. So it's not that we keep it all for ourselves, it's also helping actually the customer to make some money with it. So we hope to change the business by not only pushing from technology, but also on business models. So the key question that had to be answered here in this specific topic is next-gen generators and backup power. And as you can see, there are a few things you can do in our perspective. But the key question is I think, something that not all techies like to hear, but it's how much money, time, and effort do you want to spend on something that is actually being used in a stable grid situation like in the Netherlands, only at least, no, let's say maximum 1 day a year. So we can do all kind of forward-looking, really nice niche technology testing, but also our investments have to make sense. So here, actually, you see what we could be doing is replacing our current diesel with HVO. I'm not sure whether you're aware of HVO, but there was a nice white paper by our colleagues in the UK from Colo, and actually that showed that that you can already save 90% of emissions if you start using HVO instead of diesel. Of course, your generators, your gensets have to be capable of supporting that. And indeed, there is a small price difference in HVO versus the diesel, but the amount of emission impact you can generate there is that structural that for us it is a no-brainer to start doing this. So it is a relatively cheap way of doing something and greening up your next-gen generators. But also there are other options, and I think you all are aware of all kind of activities around battery sets, but also hydroxygen is, I think, a very important alternative that is currently still a little bit in the development phase, but it will definitely at a certain point in time become a more sensible thing to look at. So there are even other options, and I know there are some countries where people like to talk about nuclear generators and nuclear whatever. In the Netherlands, it is not so favored to put a nuclear reactor in the middle of a city environment. So despite the fact that that it could be technically a nice solution, I think we have to convince quite a few people that this is doable. And that's, again, also one of the reasons why we see, for instance, hydroxygen still also being slightly of a difficult solution. Reason why we think it is difficult because we mainly focus on our deployments in the city environment around Amsterdam. And as you all know, hydroxygen is still kind of explosive if you don't store it properly. And municipalities are not always that keen on storing large amounts of hydroxygen. That could change in the coming years, specifically because it's also a large push from the national government to shift more from gas to hydroxygen. But still, there's a lot of regulations in place that don't make it an easy option. So yes, we think it is a potentially interesting area, but there are a lot of downside also in doing something with hydroxygen. One of the real downsides, for instance, is that it takes quite some time to get your systems up to speed if they work with hydroxygen. And you should actually keep still, for instance, 15% of hydroxygen running while you have 85% still working on diesel in your gen sets, unless you actually switch to the full hydroxygen usage. But the startup time of hydroxygen is still a thing we are looking into. So as you can see in this slide, we have a very, let's say, down-to-earth preference for using HVO, and because of actually the cost impact is relatively minimal. We don't have to replace all kind of technology, but still, as I said, we are looking into alternative technologies parallel. So there are some operators in the Netherlands. Actually, there's a competitor called North Sea who just actually deployed an H2 generator in the Netherlands, which is a nice headline as making marketing impact. And of course, it also has some positioning impact. But at this point in time, we consider it more of an, let's say, image thing than that it's a large scale saving or actually helps contributing large-scale CO2 reductions on this scale. But again, it's not that we're against H2. Actually, we think it's a pretty interesting area to look into. And innovative as we are, we already have been quite actively talking to the supplier of this H2 genset that was deployed recently by our competitor, but we already talked to this party 3 years ago. And we did the analysis and we did the business cases and actually decided to, for this moment, still look what's happening. But as I said, the impact can increase. So if you plot the return on investment and the image in one graph, you see that actually the return on investment on H2 is still pretty low in our perspective, but the image is of course pretty good. And there's HVO is a little bit the other thing. Not a lot of people are looking at HVO. So image-wise, it doesn't score unless you actually are able to show people that it saves 90% of emissions, and then suddenly it becomes a big thing. And also, I think the more HVO is being deployed, the cheaper the HVO will become, and therefore the return on investment will also be better and better. Batteries are in between. There's a lot of battery solutions, pretty expensive, but also you can earn them back if you start doing peak shaving and actually use them for a low. When there's a lot of energy over capacity in the network, you can store it. So the combination of batteries and gensets is an interesting one. And also there we are still looking into it. Not deploying, but we are just like in H2, we are very much following the potential. And it could very well be that in certain business cases, it starts making sense to deploy those. So all in all, I think this is a very technology-oriented debate. And unfortunately, optimizing the CO2 impact and imprint of your company is not only about technology. Actually, there's a lot more things you can do. And there's a lot more choices actually you have to make in order to optimize the full CO2 imprint of your company. And therefore, I think it's a message that not everybody likes in the industry, but it's not the CTO's job to run the CO2 impact. It's the total management team actually to be very actively contributing in making the most optimal CO2 decisions. And for me, that's a very important thing to keep in mind. Despite the fact that we're very much technology oriented, it is very important that we keep track of the total return on investment and also the total impact of $1 spent on this on the full impact of your CO2 imprint. Main reason why I say this, and that's maybe different than in the US, but in Europe, very recently there was a new reporting rule adapted for multinationals. And also that will go for our customers, but also for data centers. And that's not that currently everybody's used to scope 1 and 2 impact of your emissions, but the new thing is that you also now have to report the scope 3. And the scope 3 is a very unclear thing and not so so much known by companies who are not in the EU, but that is actually everything that has to do with your full offering and actually was caused by suppliers and others. And the most important scope 3 impact that we see if we build data centers is actually caused by the building itself. So how much truck rolls do you need? How much concrete slab do you put in place? And I think specifically the last one, the concrete that is being poured into new data centers has such a negative scope 3 impact that we think it is way smarter if you do the full scope analysis of your data center, not only to look into the technology, which is much more in scope 1 and scope 2, but very much optimize on your scope 3, which will become very important for your large customers and hyperscalers who also will be reporting scope 3. So our main focus is on trying to minimize scope 3 while we also optimize scope 1 and 2. And that's different than all other data center operators. And that's also a reason why we actually prefer to redevelop buildings that are already in place into data centers using a box-in-a-box principle. And most of the time actually keeping the concrete slab in place. If the concrete slab already exists because it's a reuse of, for instance, a distribution center, then suddenly your scope 3 is heavily decreased, and you will stand out from all the others that are building new data centers. This is not known to everybody yet, but it will be a big differentiator, and that's where we at Switch already take a very proactive approach. So I don't want to be ruining a party of people who like to hear everything about generators. But the story here is it's not only about the technology, it's actually about the full holistic scope of your business. And if you optimize that full holistic scope, you can have much more impact with certain dollars than if you just start to experiment with very, let's say, expensive new equipment, which in the end only contributes a little to your total scope emission picture. So maybe not the message you have been looking for, but I think you have to see all in balance, and specifically the impact of scope 3 is something that is very, very much overlooked by a lot of people. But this will change in the coming years. So that's why we are at Switch really pushing the industry again to do things differently. And we also see already a lot of resonation of this with the larger hyperscaler type of accounts who really understand the importance of scope 3 and will have to report on scope 3. So this is not something that is there for the bookkeeping or for the CFO to deal with. This is a crucial element that will change also how we build, design, and run data centers. So for Switch, this is how we do it. We take a full perspective on all CO2 imprint, and therefore the importance of only looking at some technical elements that are only used, let's say, one day in a full year, is becoming less of a boardroom topic than looking at the total picture. So having said that, here you can see that we redevelop a lot of plots. Actually, this is what we are currently doing. And out of all the plots shown in this picture, there's only one new build area data center. The rest has been redeveloped. And as you can see, we are specializing in redeveloping distribution halls into data centers. And our AMS3 data center, for instance, still looks on the outside 100% like a distribution center, but the inside is a box-in-box tier 3 data center, currently in the financial heart of Amsterdam. So we have done this already for quite some time, and we are also doing new developments, as you can see on the bottom, of very, very large distribution halls in place that we redevelop into data centers, saving massive amounts of scope 3, but also speeding up the construction, of course, rapidly. So why do we do these things? Maybe this is another slide that came out of an earlier presentation we did. We think actually the whole business model about data centers currently is way too much around technology and way too little about understanding the holistic picture. And what we think data centers 2.0 will be is something else than what you consider a data center right now. We think the heat being generated in a data center will become very more important. And again, actually the data center, which is currently only being used as a cooling plant for some servers, might change, in our perspective, into a city heating plant. So the heat being generated in a data center suddenly becomes much more important than it's currently is in the current way of looking. And specifically, again, if you want to put your data center in a city environment, we think it makes sense to have green PPAs coming into this city data center. We prefer to have, of course, liquid cooling there because it generates 50 degrees plus return heat. And that return heat will then be fed into district heating networks that currently are popping out everywhere due to the gas crisis. And therefore, we can actually generate with green power in, the PPAs, green heat out. And that's, of course, a win-win for everybody in a city environment. And then suddenly you're not talking about a data center in itself. Now, suddenly you become part of an ecosystem where people start liking data centers because you actually add value and you help municipal environments to green up their imprint in the city, and actually can generate green heat end to end. This is another thing we do, and as said in this picture, the only new site we're currently building is the EMS5 site, which will be directly built at the entrance point of the heat network of Amsterdam. So we will put this plant just in between the gas turbines that are currently producing the heat for the city heating network and the pipes where it actually is being fed from. So this will become an electric heater for the city of Amsterdam. Again, different concept, and you have to think much broader than what majority of the people are doing in data centers, and that's why we call it data center 2.0. So this is a slide where I actually say what we're currently doing. I already discussed EMS5. EMS2 is more or less our lab environment where we in real life test out what we do, and because we can heat up the building next door. So that's an easy one. This has been already discussed in an other call where we actually state that we are much more a believer in liquid cooling than in air cooling, and actually see a change coming up that's comparable to driving diesel towards driving electric cars. And it's a big change we need to make as an industry, but there is so much that we can gain from it once we all adapt it. So we actually are in favor of liquid cooling and all kind of forms. So we're not believers in one specific technology, but what we're really after is the high temperature heat being generated. So again, as said, we are a challenger in the industry. We like to think totally different than all the other data centers, not always understood by the standard data center folks, but I think they will in the future. There was a guy once building Tesla in his garage. He was not understood by a lot of people. We don't pretend to be that size, but we like to challenge ecosystems, and we like to be different. And the fact that we're growing like crazy with Switch in Amsterdam and adding one site a year shows that we're on the right track. And also very, very large customers now know to find us. And it's really interesting to see the traction that we have by thinking totally different, out of the box, and not considering a data center just a bunch of technology, but as a total ecosystem in a city environment where we have to minimize the scope 1, 2, and 3 emissions for all parties. So food for thought. If you have any questions, feel free to reach out to us. Specifically, if you have large amounts of megawatts running on liquid cooling, and then I'm not pointing towards Bitcoin miners, but to others like AI, give us a call, and we definitely would like to integrate your heat into our vision. Thank you very much, and it was good to have this talk. Again, you can find us on the internet, www.switchdatacenters.com. Thank you very much. Bye-bye.